Hey Defenders, welcome back. In this video, I want to cover Pi-hole and what it is, what it does, and how we can use it to help secure our networks. So stay tuned and we'll jump into it. But first, time for my shameless plug. If you want to learn more about our company, head on over to opensecure.co. If you would like to hire us for a project, select the Contact Us link in the description of this video. To see firsthand the power of open source, take advantage of our interactive demo. Select the demo link in the description of this video to start exploring. Now let's get back to the video. So Pi-hole is an open source DNS server that we can spin up and run that will handle DNS queries for us. And it's fully configurable on our end, so we can whitelist domains, we can blacklist domains. We can get sophisticated to what domains our internal hosts can resolve, right? And we have the flexibility to install Pi-hole and configure it to be our DNS server. And the goal of this will be to stop malicious domains from being resolved by our internal servers. But before we get into that, I want to kind of go over the basics of DNS and kind of what this tool, how this tool provides the security for us. So I'll jump over to just a very, very dumbed down version of DNS queries and kind of how that works. So step one, we have our internal server, right? And he says, and our internal server says, hey, I want to connect to, let's say, opensecure.co. So if I just run a simple command to ping to opensecure.co, we see that the domain name is resolved to an IP address. And so what's doing that for us? Well, that is our DNS server that we are connecting to, right? So I have within CentOS, and in every operating system has a resolve, has a file that holds name servers, right? And so in CentOS in the Linux world, it's the resolve.conf, which is under the etc directory. And you can see I have my two name servers. And these are just Google name servers, and this comes pre-bundled with whenever I install an operating system from the cloud provider that I use. And if I were to remove these two guys, so my name server config file is empty, and I try to ping opensecure.co, you see I can't resolve it, but I could still ping the IP address, right? And so that's what's happening under the hood. So my internal server tries to resolve opensecure.co, and to do that, it looks within its resolve.conf and would see a name server. One of Google's is just 8.8.8.8. So if I can spell that right, and then save that off, and then try to ping opensecure.co, you see we can do it again. So what's happening is our internal server is saying, hey, I need the IP address of this domain name opensecure.co. He reaches out to our DNS server, which in this case is Google's 8.8.8.8, and says, hey, what's the address of opensecure.co? Our name server says, hey, the IP address is 185.230.63.186, and sends that back to our internal server. Our internal server says, okay, great, and then is able to traverse the internet. Since it knows the destination of where it's trying to get to, it's able to then traverse the internet and connect to opensecure.co. And shameless plug, go ahead and check out that website if you haven't already. and is able to connect to opensecure.co and interact with whatever opensecure.co is broadcasting, right? So that's just a very dumbed down version of DNS. There's more complexities in different name servers, mail servers. It gets more complex with subdomains, and you can dig pretty deep into DNS. But that's out of the scope of this video. And so how can a DNS server provide us the added protection, right? Well, since we are resolving domain names, right, our DNS server knows every request that comes to it, right? So our DNS server here saw that we made a request to opensecure.co. If I ping youtube.com, our DNS server knows that, hey, we made a request to youtube.com. Well, what if some malware gets on a server, or someone gets onto a server who shouldn't have access and tries to download malware from a command and control server, and let's say they host it at www.hacker.com, right? And so say someone is actually able to do this, so then our internal server says, hey, what is the address of hacker.com? Our DNS server would see this request, and if it is a legitimate domain name, let's see, out of curiosity, if hacker.com actually exists. And it doesn't. But say it did. Say it resolved to an IP address of 1.1.1.1.69. Nice. And our DNS server would then resolve that IP address for them. And our internal server would say, okay, cool. Or so our DNS server would say the address is 1.1.1.69. Nice. And our internal server says, okay, cool, I'm going to connect to hacker.com because I know the IP address. And so the advantage of controlling your own DNS server is we could blacklist specific domains. So our internal server could say, hey, what is the address of hacker.com? Our DNS server says, oh, no, that's blacklisted. I am not going to let you request that. And I will throw a big X over your request, and I'm not going to respond to you, right? And so then the internal server says, oh, okay, I guess I can't resolve hacker.com, and it'll give us an error like what we saw here, name or service not known. And then that's it. The internal server then doesn't reach out to hacker.com to grab any malicious software, right, that a hacker may be trying to grab. So we can also, instead of blacklisting, we can also do a DNS black hole, right? And that's a technique where our DNS server will resolve hacker.com, but it'll resolve it to an internal address that we have set up for black holing. So say I'll do 192.0.0.69. Nice. And what he'll do, and this address will be a private IP address that's within our internal network. And so now, instead of our internal server traversing the internet and actually going to hacker.com, our internal server gets this domain resolved to 192.0.0.69 and actually tries to connect to our internal server down here, which of course isn't hosting anything malicious. So an attacker is now not able to progress down the kill chain and get software that they've hosted within out on one of their domains that they have, or maybe they've hijacked a domain in some serious cases, and now they're not actually able to grab the software that they are wanting to grab. All right, so that's kind of sums up a very brief intro into DNS. If you have any other questions about it, or if there's a good chance I made some errors as well, let me know in the comments and I'll address those there. But let's go ahead and move on to installing our DNS server. And we're going to use Pi-hole for that. This is an open source tool. You can check out their website, piehole.net, and they have a GitHub, they have community blog. And so let's go ahead and go into their documentation. Prereqs, they don't require much hardware to get this spun up. However, if you are replacing this with a DNS server in your production environment, make sure it's beefy enough to handle the amount of DNS queries that your internal hosts make, right? So depending on the size of your internal network will have a direct correlation to how beefy this box needs to be. So for this demo, I'm going to install it on a CentOS box. And I'll go ahead and go into installation, and they have a bash script that we can easily run to to install this. So I'll cd into opt, I'll run my command, I'll make this bigger for you guys. And we are now going through the install process. Asking if we want to trust this repo, sure. And I'll skip ahead until we're actually interacting with the script. Okay, and so now we are progressing. That's for donations. So it needs a static IP address. Okay, yeah, that's fine. You would want to make sure that if you're looking to stand this up in your home environment, you may need to tweak your router to disallow DHCP and to set a static IP address to the server that you're standing this up on. Asking for the upstream DNS provider. So when our Pi-hole is made a request, right? So when our internal server says, "Hey, I need to resolve this domain. What's the address?" We're gonna tell our Pi-hole server to trust, or actually I can just copy and paste this, to trust. We'll just use Google's DNS server. So it'll DNS kind of works on a hierarchy principle. So Google, we're going to trust Google's DNS servers to resolve it and then return it back to us, right? And then the DNS server, our Pi-hole server, will then send it to our internal server, and our internal server will go out. So we're going to say yes to that. It is going to ask us if we want to download a third-party list, and these lists will contain domains that we want to block. Select protocols. Yep, so v4 and v6. Then we have our static IP address. Yep, that looks right. So they're warning you here again about your IP conflict with DHCP. So you again want to set a static IP address. They're just reminding you of that again. Yes to the web admin. And yes to the web server, and yes, we want to log queries, and yeah, I want to show everything. All right, so our selections are made, and now it's finishing the install process for us. And you can see using upstream DNS, you see the same IP address, right, that we were looking at earlier in our resolve.conf. All right, so it looks like our install is complete. Let me go ahead and take a sniff of this. So we see that we're going to connect to this guy, to the web UI, and DNS wise, we're going to make our DNS request to this IP address here. Some install log. Okay, the web interface is spun up here so we can connect, and then we have our admin password. Okay, so let's go ahead and log on to that guy. So I'll throw that to the side. And I will connect to 78.138.31.131/admin. And we're not getting anything. Oh, I bet. Let me stop firewall D. And there we go. Okay, so a local firewall was running on the server that was stopping that. Okay, so that looks good. Oh, we still need to log in. So we get a nice little dashboard here. We will log in with our admin account. Okay, we will log in. All right, cool. All right, and now let's go ahead and check out our ad list. So we actually said yes to that guys, right, during the install. So it populated this list for us. So if we follow this is just stored out on GitHub, and this guy has this list of domains that I guess are associated with advertisements. And so we're going to be blocking those. And what's nice is we can just point to a specific URL. If you can add custom domains or blacklists. So say I want to blacklistyoutube.com, I would say it there and then add to blacklist, right? Or you can do it as a wildcard, which is cool. Or we can bring in our ad list. So if I go into group management, go into ad list, and they call it ad list, but you could also think of it as blacklist, even though I know they have a separate feature for that, but it's still going to block any traffic that tries to go to this domain, right? And what's nice is we can point to just URLs. So like I'm on Reddit here, and they say many of us use this list from this GitHub, and we see all of these URLs here that link to populated and are constantly being updated, which is nice, of malicious domains that have been associated with malware or phishing attacks. So let's click one of these. Here's a phishing army block list. So if we select that, we see that it was last updated today, so that's good. You want to make sure you're getting a list that's always populated. We can see all of these domains. Look how many of them are that are malicious or have been associated with phishing. So this would be something great to set up like in a corporate environment or network where your employees are on when they are checking emails, right? So then if they were to open up a phishing email that tried to access one of these domains, Pi-hole would actually block it, right? So we would actually stop a phishing attack within its tracks. So let's go ahead and copy this URL. We'll go back to our web UI, and it's as easy as just pasting it in there. So we'll say add, and you can see it's enabled, and we will need to, let's go ahead and update it. So we'll select update. We'll go to the tools and update gravity, and we'll go ahead and update it so it'll read the URL that we specified and bring in the domains. And look how many we brought in. 29,000 malicious domains just by pointing to a URL, right? Which is awesome. So I could add many of these lists if I wanted to, right? And we have this automated process, and these lists are always being updated, which is nice. So okay, so we have our basic lists. So we have our DNS server stood up. We've populated it with some malicious domains, and now we need to tell our internal server, hey, you're going to use this server as your DNS server. So on the Pi-hole server, if I netstat this out, netstat command not found. I must have to install NetTools. Okay, here we see the server is listening on port 53, which is the default port for DNS traffic. So when our internal says, hey, what's the address of hacker.com, we are going to ask, our traffic is going to go, the direction of our traffic will go, in this case, internal server, which, if I grab the IP address, is this guy. So we will go, let me make this a little bigger. Our internal server is that IP address, and we're going to ask our DNS server, which will point to our Pi-hole server, which is listening on this address, and port 53, because that's the port that the DNS service is listening on, right? So let's go ahead and configure that. So what I'll need to do is just as easily as editing the resolve.conf file. Instead of going out to Google's name servers, let's ask Pi-hole. So we'll do that, we'll save it off, and now let's see if we can ping opensecure.co. And sure enough, we can. Okay, good. So we know that's working. And if we go back into Pi-hole, go into dashboards, look at that. We can see our queries coming through. So if I select my query log, you can see that we asked for opensecure.co, right? How cool is that? We see some other, we see Google's upstream domain servers come into play here, right? Because we, under our, what was that, settings, right? Our upstream DNS servers are Google's, right? So we're using Google's here. Cloudflare is a pretty good one. They actually do some DNS blacklisting of their, some domain blacklisting of their own, which is cool. So they're a good one to trust. So if I change that and then save, so I've changed to their DNS servers. And if we run a similar command, we should, and now if we look for, let's say, youtube.com this time, all right, we're able to resolve it. And if I go into my queries log, we should see some Cloudflare servers taking, and now we see, so Cloudflare, that's funny, their IP address of their DNS servers is 1.1.1.1, and they actually have like forwarded to 1.1.1.1. That's like their domain. That's funny. But so now we're logging our DNS queries, right? Like how cool is that? So now any internal server that's on my network, I can easily grab a list of domains that they're trying to resolve, which is a great addition to our security footprint, right? And security platform that we have. Okay, so now, so we got that working. Our server, our internal server is using our DNS server. Now let's see what happens if we try to ping a no malicious domain. So let's say I want to ping this guy. So if I get back onto my client here and I say ping here, oh, look at that. So we're doing our black holing, right? So this is actually resolving to a just internal, this is just a local host, right? So now if we go back with local host of our Pi-hole. So if we go back into here, we see queries blocked. Now we see this being populated, right? That's cool. And if we go into our query log, I think we could probably filter on queries blocked. Can I select that? Oh, here we go. So top block domains, we see this guy being blocked, right? How cool is that? And then I also see the server that made the request, right? And so I can say, so then if we got an alert saying, hey, one of your internal servers tried to resolve a malicious domain, you know, this is the server that did it. Now we can go investigate and investigate further, and you get the IP address of the server that made the request, right? And your server is only going to make a malicious, your server is only going to make a domain request if software is trying to do it. So some malicious software gets on the server that's trying to download something from a domain that's hosting, or if a user is using your client server to try to interact with a malicious domain, right? So your server isn't just going to make queries out to malicious domains by itself, right? There's going to be something on there, whether it's software or a malicious user that is making those requests, right? And this is a great tool to not only see malicious requests being made, but to actually stop them in their tracks. And we have this wealth of information around us in terms of, you know, we can access the logs and see who made the exact request. And in terms of our internal server thinks, oh, I did resolve it. And I'll try to reach out to this address, which is just a local host. If we run an if config, you can see by default a loopback interface is always this 127.0.0.1. And that's how Pi-hole is black holing a malicious domain that we're trying to resolve, right? Which is, in this case, 127.0.0.1. So pretty cool. This can really benefit your security platform. Again, you would need to make sure that, and we can also whitelist domains, right? So if it's a company-owned domain like opensecure.co, I know I can trust this domain. I can go ahead and add that to a whitelist. So even if it does appear within a list somehow, we know that it is whitelisted. Or you could be like really strict and not allow and disallow all domains. You can blacklist all domains and only allow what's on your whitelist, right? Which would be domains that you approve. So you could even you could really lock down your network to say, our servers are only accessing domains that we trust and we know that we can trust. So you can get as strict or as lenient as you want, but you now have the ability to stop your internal servers from resolving a malicious domain, right? And you also now know who has made what queries. And you can also, you have these little quick action buttons on the side. So if users start complaining, hey, I all of a sudden can't get out to this domain, you see it in their log, you can say, okay, let's go ahead and whitelist this guy. So now it's added to the whitelist. If we go to our whitelist, we'll see the domain here, right? And we could remove that if we wanted to as well. So really powerful, right? And gives us a lot of insight, which is awesome. And it comes with this nice little web UI, so we can have a little dashboard and we can interact with our server accordingly. So I appreciate you guys hanging out with me, and I will see you in the next video. Hey Defenders, I wanted to make you guys aware about a Slack channel that I've just created. I'm hoping we can use this channel to discuss any questions you guys may have, any new open source tools that you guys want to explore, talk any sports, and just get to know each other. There is a link in the description, and I hope to see you guys there.